Okay, ladies and gentlemen, what we're going to do now is we're going to start talking about systems and solving systems of linear equations. Now, a system of linear equations, well, a system is a combination of any number of items, okay? So if I have a computer system, I have a computer, a keyboard, a mouse, a monitor, maybe a printer. The whole thing makes up a system. If I have a water system, I have some sort of pump, I have pipes, I have faucets, I have outlets, I have drains, and the whole thing makes a system. Okay, so a system is something that has multiple components. Well, what we're going to do is we're going to talk about a linear system, a system of linear equations. Now, I can have a linear equation. If I have y equals 3x plus 1, I go up 1, and then from there I go up 1, 2, 3 over 1, draw a line. And that's a perfectly good line, and that is a linear equation. But if I have another line, y equals negative 1/2 plus 3. Negative 1/2 plus 3, I'm going to go up 1, 2, 3, and then from there I'm going to go down 1 over 1, 2. Down 1 over 1, 2. And from there I can put that line on the graph. And there we go. So now what I have is two linear equations, and those two linear equations can form a system. Now, what we're looking for in this case is if I have a system of equations, everything involved in this line is confined to this line. Everything in this line is confined to this line, except right there at the middle, where they cross. That would be a solution to the system. Now, a solution to the system would be one set of values that not just works for this equation, but also works for this equation. So in this case, whatever this x is and this y is right there would work for x and y here and here. Now, we're going to talk about different ways to find that value, that solution to that system. But if we think about lines, there's a couple ways lines could be related. I could have lines that are like this, and they cross just like we have over here. In this case, we would call them independent. And they cross in one place, so I have one solution. Here, I could have two lines, but those lines could be totally parallel. And those lines that are parallel would be dependent, and they would have no solutions. And now the interesting thing, of course, about parallel lines is the slope on this line is going to be the slope same as the slope on this line. So we have the same slope in both cases. They never intersect. The final situation where we could have two lines put together actually looks like just one line, because I can take an orange line and I can put a black line right on top of it, and that's two different lines, but they really just look like one line because we put one right on top of the other. So we have independent, one solution, dependent, no solution, and we have dependent, and in this case, every point on the black line is also on the orange line, and so we have an infinite set of solutions. An infinite set of solutions means there's infinitely many. There is no limit to how many solutions there are. So that's a basic set on solving systems of linear equality, but we're going to do a couple methods, and the three methods, you need to know the names of them. Three methods for solving. The ones we're going to talk about is number one, graphing. Number two, we're going to use elimination. And number three, substitution. So to solve a system of linear equations, which is two equations which may either cross, be parallel, or right on top of each other, we're going to either use graphing, elimination, or substitution. So from there, we'll take a look.